Each day, thousands of people move around the Purdue University campus, and it is important that they get around safely. Therefore, Purdue's Safety Committee wants to minimize the number of crashes and near misses between pedestrians and cyclists on campus. In fact, Purdue EMS reported that there has been close to 100 pedestrian injuries on campus, which required emergency care within the past from 2014 to 2017.
The stakeholders of Purdue University who cares about student safety on the road, bikers, and pedestrians who will be the most advanced by the increased safety by reducing injuries and lost time.
A major constraint is budgetary restrictions. We must be sure that our solution must not affect the cost of education on campus. It must be safe, causing no harm to the users, and reliable, being able to work for a long time under extreme weather conditions. At the end of the day, the solution must be aesthetically pleasing and applicable elsewhere.
In order to devise a solution, we started off by brainstorming over 50 basic ideas. We brought that number down to 3 by creating sketches, models, and prototypes and seeing how well they fit our criteria and constraints.
The first solution was to add a bike lane to the engineering fountain. This is important because the lack of a bike path here causes pedestrian accidents with weaving bikers. We believe the solution is good because more than 3/4 of respondents to our survey say they would be inclined to use such a bike lane.
The second solution was to create a system which would warn distracted pedestrians of oncoming bike traffic that would help prevent collisions. This is important because according to a typical New York County report, almost 50% of pedestrian bike collisions occurred because they failed to yield one another.
The third solution was to add pedestrian steamers to crosswalks in order to prevent jaywalking. This was inspired by a system being tested at an intersection in China right now. However, this solution received very mixed reviews from the survey respondents, and there was no consensus on the aesthetics or the effectiveness of the solution.
Now that we had the solutions, we had to find out which one was the best. This is where the weighted decision matrix came in. We weighted the criteria and assigned scores to each solution. The matrix ultimately decided the LED bike warning system, and we decided to pursue it further.
Continuing the design process, we began building physical prototypes, and an early form of this was a functional one built from cardboard, TI board, and ultrasonic sensors. This helped demonstrate the basic functionality of the solution and ultimately led up to our CAD model shown here.
However, we found that the ultrasonic sensor has bad ranges, inconsistent readings, and spikes. After team discussions, we resorted to a spike movie favorite, laser tripwire across the path. We also switched from red LEDs to RGB LEDs so that we can have different color for context.
Finally, we set out to build a testable and larger scale model of the solution. We purchased some cheap parts online and worked our way up to developing a test unit one component at a time. This is iterative design, and it was crucial to our success. After we were able to complete the prototype, and a trial run of about 50 tests in the real-world conditions showed that the laser system tripped accurately 100% at a time, a significantly better improvement from the ultrasonic sensors.
Before we conclude, we want to address assumptions. When pricing our solutions, Purdue's infrastructure budget was not available, so we used the total capital budget for the whole school year instead. For the pedestrian steamer, our source included the price for things that are outside the scope of implementation. Therefore, we assumed that the price of the steamers was still pretty significant. We also had to assume that the data received from the students surveyed are educated answers and will represent their true opinions.
After all, we believe the final solution is valuable because it is the most effective solution to prevent accidents by increasing awareness. It is also cheap, taking less than 0.01% of Purdue's budget, while also fitting into the modern looks of the engineering mall. This conclusion came from data analyzed from a survey we conducted on current, past, and future Purdue students. We hope you like our idea, and as always, thanks for watching.